Welcome to all. In this video, I am going to explain about how to find the frictional power in retardation method. The main aim of this experiment is to determine the frictional power of a 4-stroke single-cylinder diesel engine by retardation. Apparatus required for this experiment is 4-stroke single-cylinder diesel engine with eddy current dynamometer. Coming to the procedure, first start the engine with the help of crank lever at no load condition and allow the engine to run some time until to get the stability in the speed. Now connect the generator by applying the changeover switch towards generator position. Here all the electrical load switches at off position, which means the engine runs at no load condition. Now cut off the fuel supply and note down the time taken for the speed fall to 40%, 60% and 80% of the rated speed, which means we need to take the time fall for the speed at 1200 rpm, 900 rpm and 600 rpm. Now repeat the same procedure by applying 50% load on the engine and note down the readings, which means we need to apply 3 kilowatt load on the engine. Now all the readings are noted in the table as shown here. Next, draw the graph for no load and 50% load conditions. Take speed on y-axis and take time of fall on x-axis. From the graph, the time required to fall through the same range means 100 rpm in both no load and 50% load conditions are noted. Here T2 is equal to time fall of 100 rpm at no load condition and T3 is equal to time fall of 100 rpm at 50% load condition. By following these model calculations, you can calculate the frictional power. The formula for frictional power in retardation method is 2 pi n by 60 into Tf. Here Tf means frictional torque and it is equal to T3 by T2 minus T3 into TL. Here T2 and T3 will get from the graph directly, where TL is equal to a load torque at 50% load condition. Therefore TL is equal to P into 60 by 2 pi n. Here n is equal to rated speed, that means 1500 rpm, and power P is equal to 3.73. Now substitute all the values in the equation, you will get TL is equal to 0.0237. Now substitute TL and T2, T3 values in TF equation, then you will get TF as 0.1422 watts. Now substitute TF value in frictional power formula, then you will get FP as 22.33 watts. So this is the final frictional power.